everybody, it's Betsy here, and today we are going to solve inequalities. Yay! How do I know I'm working with inequalities? Because we have less than and greater than symbols. If it was an equal sign, then we'd have an equation. And when we solve inequalities, they're very similar to equations with just a little extra rule. When you divide or multiply both sides of an inequality by a negative number, you have to switch the inequality around. So if you started with a less than symbol, you would end with a greater than symbol. And that's something I'm going to show you today. So let's get started here. So number one, we have 3x minus 4 is less than or equal to x minus 6. So the first thing we're going to do, just like we would with equations, is we're going to get our letters on the same side, our variables. Now I like to make my line down here, so I'll make a line down here, keep the two sides separated. And then I'm going to take this positive 1x here and I'm going to bring it to the other side. And how am I going to do that? I'm going to subtract 1x. Whatever I do to one side, I have to do to the other. So there we go. When I do that, I get 3x minus 1x is 2x. I'm going to bring down this negative 4. Don't forget the minus in front. I'm going to bring down my inequality, less than or equal to. These are going to cancel, and I'm going to bring down my negative 6 or minus 6. All right, now I've got all my x's together. I like to box that term out because I know it's the last thing I'm going to do. So I'm going to make a nice box around that. And I'm going to leave it till the end. Whatever's outside that box has to go to the other side of the inequality. So what are we moving there? I see a negative 4 or minus 4. That has to go to the other side. And how are we going to do that? We're going to neutralize it. It's a minus 4, so what do we add to both sides? Yes, a positive 4. Remember, we got to stay balanced. So whatever you do to one side, you got to do to the other. Now, when I do that, I bring down that 2x, bring that down. These cancel. Bring down my inequality just the way it is. Now, I've got 6 negatives and 4 positives. The 6 is bigger and it's negative, so it's going to be negative. And then just subtract. 6 take away 4 is 2. We're getting closer. Now I have 2 times x is less than or equal to negative 2. I don't want 2 times x. What do we want? Yes, we want x. They're timesing, so we're going to divide. And whatever we do to one side, we have to do to the other. So when I do that, 2 divided by 2 is 1. I'm left with x. I'm going to bring down my inequality just the way it is. A negative divided by a positive is a negative. And 2 divided by 2 is 1. So I get x is less than or equal to negative 1. All right. I did not divide or multiply both sides by a negative, so I didn't have to switch my inequality. Let's take a look at graphing this and what that means. So we're graphing the values of x. So I'm going to put an x on the outside because that's what we're looking at. Now I'm going to put a 0 as a starting point. So negative 1, 1, and so on. When you graph this, I'm graphing all the solutions, everything that x can be that'll keep this inequality true. And our answer is telling us x can be anything less than or equal to negative 1. If it's less than or equal to or greater than or equal to, we have a solid dot. If it was just less than or greater than, we'd have an open dot. It's solid because we're including the negative 1. So I'm going to go up to negative 1 and I'm going to put a solid dot there. And we're saying anything less than or equal to negative 1 will work in that inequality. So I'm going to shade to the left. Make sure you shade that arrow because it includes everything in that direction. Negative 1 million will work. Now, just a little hint to give you. When you solve your inequalities, if your variable, your letter, ends up on the left side, when you shade, it's going to be whichever direction your inequality is pointing. My inequality is pointing to the left, we shade it to the left. All right. If the letter is on the right side, you would do the opposite. So I have x is less than or equal to -1, which is the same thing as -1 is greater than or equal to x. So if your letter is on the right side, you shade the opposite direction that it's pointing to. Just a suggestion if you have trouble remembering that. But I like to get my variable on the left side, and then I can just follow the inequality. So let's take a look at the next one. All right, I'm going to make my line through it so I can separate my two sides. And next, I'm purposely going to make my x's negative so that we have to make a change, a switch. So I'm going to bring this positive 2x to the other side by making it negative 2x. And what I do to one side, I've got to do to the other. We got to stay balanced. So there we go. Now, I've got a negative 3x and a negative 2x. If you have 3 negatives and 2 more negatives, that gives you 5 negatives. Then I'm going to bring down my positive 12. Remember, bring down the sign in front of it with it. Then bring down your inequality. These are gone, and I got to bring down a negative 8. The hardest thing here is the detail, paying attention to detail. Don't bring down 8, it's negative 8. Next, I got all my x's together, so what do I like to do? I like to box them off. Again, that doesn't mean that's what you wanted. That's just what I like to do, because I know once I have my variables together, that's the term I work with last. So we need to get rid of this positive 12 because it's on the same side as my box and it's got to go bye-bye. So how are we going to do that? We're going to subtract 12. And whatever we do to one side, we're going to do to the other. There we go. Now, these are gone. I can bring down my negative 5x. I can bring down my inequality. 8 negatives and 12 negatives gives you 20 negatives. Am I done here? I've got negative 5 times x is greater than negative 20. That's not x is greater than, it's negative 5 times x. So they're timesing, so we're gonna divide. And whatever we do to one side, we're gonna do to the other. And negative 5 divided by negative 5 is 1x. Now, we divided both sides by a negative. Because of that, we got to switch our inequality. It was greater than, now it's less than. All right. And then a negative divided by negative is a positive. 20 divided by 5 is 4. So we get x is less than 4. Let's go ahead and graph that. Get a different color here. So I'll say this is 0, 1, 2, 3, 4. We're graphing the values of x. I'm going to put x on the outside. Now, x is less than 4. Am I including the 4? No, it's less than 4. 3.999 will work, but 4 will not. So that's why we have an open circle, because we're not including the 4. Now, if I go back over here, you see the variables on the left side. The variables on the left side, just shade whichever way it's pointing. It's pointing to the left for inequality. So shade this way. Don't forget, shade your arrow because it goes on forever. Now, what does that tell you? Any number less than 4 that you put back into this inequality will make that inequality true. If you put 5 in, it won't work. It'll be false. If you put 4 in, it will be false. But if you put 3.9 in, it will be true. All right. I hope this was helpful. If you have any comments, please leave them. I will definitely get back to you. I hope you have an awesome day, and I'd really appreciate if you subscribe. Thank you.